This conference will now be recorded.
So, in continuation with yesterday's class, we spoke about all the different performance problems in Oracle database, right? So, regarding this IO periods, high load SQL statements, and bad application design, we already spoke about that, and we also discussed about what are all the different bottlenecks that we see from the Oracle database that are caused by environment, like CPU bottlenecks, undersized memory structures like system global area, program global area, and buffer cache. And also we have other performance issues that are caused in Oracle database, like disk IO, disk reads and writes, network, and all other different bottlenecks. And there are specific bottlenecks that are mainly caused by database. Okay, that happen only because of Oracle database. When you do any kind of performance testing, like load testing, stress testing, any kind of testing that you do, you have 50% of the issues from Oracle database, like high SQL parsing. Like we already discussed about, there are two different types of parsing. One is hard parsing and one is soft parsing. I'll explain you what is that. And we have when you do a simultaneous or concurrency testing with high user load, so there will be some repeated, there will be new database connections that get established very repeatedly. So it means that you will see high number of connections even for very low number of users, and you have to monitor at this particular value. Like when you see this high number of connections which are getting established very repeatedly on the database, you also need to look at the number of hits or the number of users or the number of transactions per second, and accordingly you need to uh, jump onto a conclusion why this is happening. Okay, this high new DP connections that are being established is one of the major bottleneck from the Oracle database side. Okay, so and like application level contention, like deadlocks in application server, like when two threads or two objects are fighting for the same resource, you also have high levels of contention in the database for small amount of data. Let's say that to fetch some data, you have very simple queries that has to be executed, and you need to get the output for that particular transaction. So search is a very basic, very basic SQL query. So if you're trying to search something from the front end, you type something like in the search box by first name or something, or Radha or Kishore or Pawan or anything. It is a simple keyword that the SQL query has to take, and it has to fetch all your data. So most of the times what it will happen is there is something like high levels of contention. Most of the DB objects are the main reason for many bottlenecks in database. What they will do is they will really struggle hard to fetch very small amount of data, and this contention, right, this level of contention can happen from any of the server. It can happen from the application server, or it can also happen from the database server. And the the last important point for the database bottlenecks are, if you're this is called DB configuration issues. Yesterday we discussed a little bit about this DB configuration issues. If your DB is not configured properly, if your DB is having too many issues, right? So then it means that the configurations from the DBA side are not done properly. So you will not be given all the permissions. You being a performance engineer, you will not be getting all the permissions on how they install this database or how they deploy different tables into the database. You will not even know what is the execution plan or what are the schema changes that happen from the Oracle database. So before you start doing this Oracle database tuning, you need to get in touch with your Oracle DBA first to understand. I mean, to if you see any of the abnormalities, if you see any of the high CPU spinning or the memory related issues or index performance, instance performance, if you see a sudden CPU spike in database activity, there are multiple things that we can take care of. But before you try to fix the performance or you understand the problem in the database, you need to understand what changes that happened in the application, what changes that happened in the database side with respect to schema changes or with respect to the database designing part or with respect to the data that has been deployed into the number of tables that we have and the number of applications that access different tables. And most importantly, you always have a data access path. If you don't know the data access path, if the data access path is incorrect or something, whatever you are trying to request from the server, the request goes to the server, but it will fail to fetch that particular response. Most of the times it will fail to fetch that appropriate data for the request that the user is sending. So before you try to fix performance or before you try to take some action on the database, you also need to ask the DBA what are all the different database configuration issues that they are seeing. I told you yesterday, if you remember, if you want to check, if you want to troubleshoot any of the main issue, you need to have this logging. You need to have this enable logging feature. For everything, you have a log feature. You can enable it to understand the root cause, what exactly is the issue. But if you give some incorrect size of any of the log file, it will record half of the information, it will log half of the information, and the remaining information will not be logged just because of not having enough size of that particular log file, and it will fail to capture all the communication between the client and the server. Most of the times, by looking at the metrics, you cannot identify the issue, right? By looking at some abnormal behaviors or by seeing some high response times, you cannot directly say that this is what is the reason I have an issue. You cannot say that. So you need to have a high level debugging. You need to have some strong experience on the Oracle side, at least writing some SQL queries or PL SQL queries, understanding how the schema can be changed, what is schema in database, or what is index, what is instance. So before you do this performance tuning, people will give you the information of the performance planning, and you have to understand on how you can tune the instance or index or any SQL query. The complete scope, if you take for any performance testing assignment, the important scope is a performance engineer has to understand on how he can analyze, take Oracle AWS report, the ADDM report. ADDM report is not rocket science. It is like you need to enable some setting from the Oracle database directly. So what it does is Oracle has some inbuilt feature, okay? Inbuilt monitor option, which you can directly enable from the suboptimal parameter settings. When you enable that, what this ADDM will do is, this ADDM is called Automatic Database Diagnostic Monitor. It will completely check the database and it will give you some recommendations and suggestions on what has to be fixed and what has to be tuned. Okay, so and there is something called ASH, which is called active session history. These are all the three important things that you need to understand very well on identifying or to ensure that something is wrong with the database. That particular point, to identify that particular situation, a performance engineer has to understand the basic Oracle AWR, ADDM, and ASH. Along with that, you need to know how to optimize the queries, how to write SQL, PL SQL query. PL SQL you cannot, it will take some time to learn, but at least if you understand how we can optimize, how we can improve it, and to check the performance of that particular query that has been optimized or fixed, you have some inbuilt analyzer tools from the Oracle database. Okay, so you can use all of them to check how, to what percentage the SQL query has been improved. Okay, to what extent it has been improved. So before we're talking about DB configuration issues, right? If again we are talking about too many checkpoints yesterday. Too many checkpoints is like when you execute something, it will verify each and every line very often, which will take a lot of time and it will impact the response times of that particular transaction. So uh, in order to understand what is completely happening from the database side, okay, uh, initially you need to baseline your DB. What does it mean actually? What do you mean by baselining the DB? How do you baseline your DB? Anyone? Only few people joined today's class, right? How many people
I
joined?
need to take AWS report uh, before in some.
Mhm. So if you want to initially understand your database, to baseline your DB, you need to take some statistics before you do your execution. Okay, so before you start your execution, there is something called application statistics, some DB statistics, operating system statistics, disk IO statistics, and network statistics. Statistics are nothing but the relevant metrics of every individual area of that particular target server. Like if you go back and see all the OS metrics on the database, if they're like I don't call it as underutilized, I would rather say they're the actual numbers before they're something like in ideal state, and those are the expected values of all application side, database side, operating system side, disk side, and network side. Before we start this testing, right, we need to ensure that everything is normally running from the database side, because most of the times database issues are like the configuration issues and the JDBC driver related issues if the application is deployed on the application server. And what you have to remember is it is not a simple three-tier architecture. You are not simply deploying a war file on an application server, and you are not you are not directly going to the application properties file, and you are not directly connecting everything to the database. What happens in real time scenario, in real time happening is, the actual real time happening is, you have to you will have n number of web app DB servers. Especially you cannot even imagine the size of production database. You will have some 7 to 8 databases, and if they are the complex applications, you will have, and that, for example, if you take the BMW client, right, we have hundreds of applications for BMW, and not all the applications in BMW will be performance tested. But again, each application that you test in this client, it should not show any negative impact on the other on the other applications which we already have in BMW. There are few applications which are interlinked, interdependent with each other. Out of hundreds of applications, we are currently testing some 10 to 15 applications. Okay, and what you have to see here is it is not a simple three-tier architecture. It has 18 databases. The application that we are currently testing with 40,000 users is having 18 database servers. And another important challenge here is all the databases that we are using are not same databases. We have Postgres, we have IBM DB2, we have DB Mongo, we have Cassandra, we have Oracle. And the recent test we have done was not, it is not very recent test. It is like it is happening from last 1 year, 18 months. It is happening. This test is called database replication testing. It means that yesterday the reason why I'm why I'm repeating a single sentence continuously. I'm highlighting one point. That point is 20% of the issues you see from the web server, 25 to 30 you see from the app server, and all the 50% of the issues you completely see from the database side. That's true. Now the customer, he has taken a feedback from all the real-time users, and what he's saying is he is seeing many issues, many performance degradations from different databases. Now, what the customer wants to try is instead of having 18 database servers we have, out of which we have 2 Oracle servers, 5 Postgres, 3 Cassandra, 2 MongoDB, 3 IBM2. So we baselined and benchmarked the database performance. We tried to monitor all the different metrics, and you being a performance engineer, you cannot be an expert of all the database. You cannot be a database guru. Even if you're a database guru who is working in industry from last 15 to 25 years, you cannot directly say that tune this parameter from IBM DB2, go back and change the schema in Oracle database, go to MySQL and change all the settings. You cannot do that. And even if you take multiple job descriptions, when you go for different interviews, you see different requirements saying that you need to have a solid experience. You need to have a rock solid experience in database tuning, SQL query tuning. Some people ask you, you need to get familiar, you need to have very good experience with Cassandra or MongoDB, which is not at all possible to any performance engineer. So we are going out of the track. So what I want to tell you here is my customer wants me to test uh, with the application with 80,000 users for 5 long days by replacing the other databases with Oracle databases. Now we have replaced all these 18 different databases with 5 Oracle databases. We are testing it with 80,000 users for 5 long days. This is nothing but database replication performance testing. It is not again baseline and benchmarking. Once you complete this 5 users 5 days testing, you will see how the performance improved using different databases in the infrastructure, and how the performance has been improved to what percentage of number the performance has improved when I tested with the same database, which are 5 target servers. You understood the point? Now, before I start the test, I take a baseline of all the statistics of all the servers, and when I start my test, I gradually increase the number of users for 5 long days. I mean, it is not that I'll not initialize all the 80,000 users concurrently or simultaneously. Maybe in the next couple of hours, in the first 6 hours, all the 80,000 users will switch to steady state, and that is where you need to start looking at all the different metrics from Oracle database, and this is where you will take multiple AWR reports. Okay, before you take this AWR report also, you need to first understand like how does your AWR collects all the statistics, and this AWR will basically tell you, or it will completely give you the information of what's happening inside your database. And if you have 5 databases, you have to take multiple AWRs, multiple snapshots, right? So like AWR, if you want to, for example, if you want to know the performance of your car, you will know the performance of your car only by looking at the dashboard, right? I mean, you can see the engine heat or out of fuel indicator, or you will see all the couple of other indicators on the dashboard, and like the AWR report is basically like a car dashboard. The first level of debugging starts by looking at the numbers and indicators that show you something right or wrong, and majority of the customers only worry about this AWR report and all the other metrics that we have in the AWR report. So taking an AWR report, understanding all the metrics in AWR report is very, very important. Okay. So as I already told you yesterday, uh, the performance tuning, right? We'll talk about AWR and other reports in detail. When the performance, when we talk about tuning, we'll especially when we go to Oracle database, right? These are all our best practices. What I'm teaching now are all our best practices uh, from the Oracle database testing that we have done. 1 minute, please. Okay, so whatever I'm teaching, these are all the different things that we have seen, different issues that we have identified for 5 long days continuously, and we have done this test very repeatedly for almost 1 year, but still 80% of the issues are not fixed. Understood? Even if you do database replication testing, you do multiple things on it, you take multiple, you do some different R&D techniques, you use different best practices on your database tuning, but you still will not get the desired performance. You know the reason why? Any idea? Any guess? We replaced all the databases with Oracle now. It's been more than a year, and we did not see the performance of the percentage of performance improved, not even by 5 to 10%. Now, if my customer is asking me why, what is your suggestion? Anyone? No idea? No one is there on the call? 11 people.
Yeah, we are able to
Is
hear
it
you.
because of the tables and these indexes?
Tables and indexes. Okay. Okay.
Then I have a question, Aki. So you say we generate the AWR and ASH reports from the database? Oh, I never knew.
No. See, AWR is like it will give you the information of what is happening inside the database. You cannot directly say this is going to happen or this is the response time of this particular thing or this is why the reason the performance is like this. You cannot give a direct conclusion on that. And AWR report, if you're running a test for 5 long days, how often do you know how often you have to take AWR report? How frequently you take it?
Well, I guess sometimes when you do the test, after the test, you can take an AWR report. But
But that will not be a best practice at all. I mean, you will not know what is the issue, because if I'm running a test for 3 hours, if I take 4 snapshots for every 1 hour, it will be easy for me to identify at what point the performance is slow. Okay, the best practice to take AWR is you can take 4 snapshots for every 1 hour or 6 snapshots for every 1 hour. You have to take more number of snapshots, AWR reports, to quickly identify the performance degradation. Okay, so yeah, I'm talking about tuning by layer. So when your test is happening continuously, the first thing that you have to check is the application issues. So when you see very high response times, the first thing before you step into database type, you have to check all, you have to fix all the GC related issues, thread dump related issues, thread issues, deadlocks, waiting threads, blocked threads. You have to fix all of them, and then you have to come to database. The first thing that you have to do is whatever the SQL and PL SQL requests are happening, whatever the PL SQL or SQL requests that are connecting or going to DB, all of them should hit the DB first of all. That is the first thing that you need to ensure. I'll tell you how to check that. How to check whether all the SQL queries and other PL SQL queries are getting executed or not is the first thing. If any of the SQL queries or PL SQL requests are not going to DB, it means that you will start seeing some exceptions from the database server saying like server not found, unauthorized error. You start seeing page not found. You will see HTTP errors other than 200. Okay, that is the first issue. That is the first thing from the application side. The first thing is you go layer by layer. You will go to the application tier and see all the application related issues, and you get a confirmation that all the application level application side issues are doing good. Okay, so then you come to this database layer. So the database layer, right? The first thing that you see is the Oracle DB parsers. This is one of the important metric. I'll tell you this one when I teach you in-depth AWR report. In this database code layer, right? You need to check the Oracle DB parsers, hard parse and soft parse, and high load SQL statements is the question. These are basically, when I say high load SQL statements, this is where you try to optimize all the SQL queries and PL SQL queries. So basically, the issues that happen across the database are just because of inefficient high load SQL statements is nothing but the SQL queries are not written efficiently. Okay, or it can be they are written in a working condition, but when they're trying to get, when they're being executed, it takes a lot of time to understand that query and to give that result, and that will impact the response time of that particular database, right? So, and there is something in database, there is one concept called object contention, and you will see like in application server you will also have objects in DB, and the main important cause for all the bottlenecks in database is the DB objects. The database objects are the source of bottlenecks because these objects, they are continuously and repeatedly accessed by all the users, right? So the same thing happens in the application server. When these DB objects are continuously accessed from multiple users, they cannot suffice the need of all the user requests, and you will see this object contention. Okay, the objects gets locked and they will not give any of the information to any of the users, which will result again in a performance bottleneck. It will give you some some error message saying that this cannot happen, right? So, and every time you say that, what when I ask you, or when someone asks you what is that you have done from Oracle database, from tuning set, you say that we have tuned SQL statements. So now tell me, you optimized SQL statements, you tried to reduce the performance, I mean, you tried to improve the performance SQL statements. And now after optimizing or tuning a specific SQL statement, my question to all of you is, did you see any impact or change in your database? Let's say that I have some 20 to 25 queries that are performing very bad. So I try to optimize all of them. Now I fixed them with the help of my senior DBA. Now, after tuning all these SQL statements, what can happen to my DB? Forget about the performance improvements. You may think that, okay, all the high load SQL statements I tuned, now what will happen to my DB? Anyone? No idea?
What is the question?
My question is, when you identify some a few high load SQL statements, now you identified all of them. Now you, with the help of your senior DBA, you try to tune or optimize a specific SQL statement. Let's say, for example, you have optimized or tuned or restructured or have rewritten some SQL statements, some 4 to 5. And after that, when you run a test, what is that you can think of what can happen to DB? Can I directly tune my SQL statements and rerun my test to see what happened with my Oracle performance? Okay. So what will happen is, when you tune a specific SQL statement, this change in the SQL statements may change the entire execution plan again, which will impact the Oracle database performance. Okay, so before you make any of the change to any of the SQL statement, high load SQL statement in the Oracle database, especially in production, you need to analyze the impact of this SQL tuning. So now the question is, how do you analyze the impact of SQL tuning? You have to analyze the impact of SQL tuning of a specific SQL query, high load SQL statement on a testing system, which is a dedicated performance environment, which is an exact mirror image of prod-like environment. You have to use a SQL performance analyzer. That is an inbuilt tool that comes with the Oracle database. If you put your query in the SQL performance analyzer, it will completely tell you the impact of that execution plan. And before you make any of the change on any of the SQL statement, you need to definitely check the impact of SQL tuning on the testing system first, initially. You cannot directly go and check the different things on testing, production database. Do not ever do any of the R&D activities, or do not, even if you tune, do not directly jump onto the production database and change it. Anyhow, you will not have any permissions or access to change all of them. But when you want to change when you want to tune any of the SQL statements, the first thing that you have to do is you need to check the impact of the execution plan before you make any change. You need to analyze the impact of this SQL tuning by testing it on a performance environment by using a tool called SQL Performance Analyzer. Okay. And after this, you need to go to the memory layer. I told you, right? Program global area, system global area, buffer cache, and you need to check all the disk layer. You need to check the read write table index data, and you also have to check read write temporary work area is another thing that you have in your Oracle database disk. So I'll send you, after this class, I'll send you the monitor's guide for all the different metrics from all the different layers of the Oracle database side. You have many metrics. It is not that you have to give all these answers, but when you explain any of the real-time scenario from the Oracle database side, you need to be very specific in all the directions, in what way or in what is the different strategy that you have used to improve the performance or to fix an issue from a Oracle database side. You can Oracle, for all the performance bottlenecks that we have from the Oracle side, you have n number of different reasons for Oracle. I can say that inefficient high load statements, or I can say the object contention, or I can say it happened because of DB parsing, high SQL parsing, or I can say it can happen because of too many checkpoints. But whatever you're saying, whatever you are trying to answer there, you need to have a proper answer for the remaining questions that will be asked from the interviewer. Okay, so what you have, the ultimate target is you need to eliminate all the bottlenecks. You need to develop efficient SQL queries, and there are two different two different ways of uh, doing performance tuning on this Oracle database server. So the way the tuning performed on Oracle database is, the first method is proactively and the second method is reactively. Okay, so proactively is nothing but they directly take the ADDM findings. I told you, right? So ADDM findings is nothing but automatic database diagnostic monitor is the abbreviation for ADDM. So I'll tell you how to enable that and from where to enable that one. So when I say tuning proactively, uh, when the test is happened, you need to enable this ADDM, and you will get some findings from the ADDM. You will get a direct report from the ADDM, and you need to review this ADDM findings. So what this ADDM report is telling, it will tell you that this index has taken this much of time. These are all the different SQL queries has taken high load time. It will give you some findings and as well as some recommendations. So for that, you need to review all the ADDM findings from the ADDM report that you get, and you have to implement all the ADDM recommendations. It is not that why a manual intervention is not required. Manual intervention is required, but whatever the ADDM recommendations that we get from the inbuilt ADDM, automatic database diagnostic monitor from the Oracle Enterprise Manager, you review all the ADDM findings, you implement ADDM recommendations. Okay, each ADDM finding will give a list of recommendations. ADDM findings will have some 8 to 10 ADDM findings, and each finding will give you a list of recommendations. For this issue, you have to change this value, you have to do this way. So all the recommendations are considered and all of them are implemented to improve the performance. Okay, so you can monitor all these performance degradations and problems in a performance page called in Enterprise Manager. You have a UI in Oracle. I'll show you when I show it to you with hands-on. I have a test database ready now. I can show you how to take the AWS report, how to do this ADDM. I can show you all of them. So after that, you can start installing the Oracle database and you can, practice on it. Okay. And to validate all these changes, you need to check the table space usage. You can look at different snapshots. You can check the utilization of recovery area, free space, and you can also check average running processes and average active sessions. Okay, this is all nothing but tuning proactively. When I say tuning reactively, so tuning reactively is nothing but you have to run your automatic database diagnostic monitor manually. Proactively is where everything happens automatically, but in reactive mode, when you plan to tune everything reactively, these are two different methods. You can follow any of the method. This is called a performance tuning method, and this is where you will directly your intervention is required, and you can see the active session history, performance problems that are short-lived. You know what is this performance problems that are short-lived? You may want to report an issue of a particular incident to your DBA. When you run a test for 4 to 5 hours, you will see an issue now, but when you try to run it again for the second time, you'll not be able to reproduce that issue. You cannot do or you cannot take any actions on such kind of situations. The reason is because that is not persistent, right? I mean, it is you cannot guarantee that the issue can happen again and again every time. When you are testing it on a testing system, on a dedicated performance environment, you cannot guarantee that the same issue can happen or it can be reproduced on a production like production databases. So the always the problem is with um, the short-lived performance problems. Okay, so for that, what you have to do is you have to continuously monitor all the metrics from the Oracle database, and you have to resolve the performance degradation over time. That means that to eliminate all these short-lived performance problems, you need to compare the database performance between two periods. Like I run a test with the same load for 5-6 hours. I for the first 3 years I monitor in a different way, and the second 3 years I monitor in a different way. But the test settings and the user load, the settings, everything is same. I can also compare the same test in 3 different phases. Like if I'm running a test for 6 hours, I can monitor every 1 hour, I can monitor every 2 hours, every 3 hours. So what I will get to know from monitoring every time, if I'm monitoring everything over time for every 2 hours or every 1 hour, so what I can do is I can eliminate these performance problems that are short-lived. So if I see any of the performance problem in the first 2 hours, I don't see the same thing in the second 2 hours. I may not see the same thing in the third phase, in the last 2 hours out of 6 hours test that I run. So for this, I have to compare my database over a time by using some different time slots. Okay, so tuning proactively, we really don't rely on that. Your intervention here is required. Performance engineer, more than a performance engineer, a senior DBA has to come in. He has to he has to review all the ADDM findings. He has to run the ADDM manually, and he has to look at all the different things that we actually have. And the last main important point here is, for example, what is that basically you monitor in database Oracle? So what you monitor is you monitor the top SQL queries, top sessions, the top services, top modules, top PL SQL, top objects, and when you monitor instance activity, you monitor the throughput, parallel execution service, and when you monitor the host activity, obviously you monitor CPU, memory, disk, and network utilizations. These are the basic metrics that you monitor. But when I say ADDM recommendations, what do you see in this ADDM recommendations is the question. The first thing is ADDM recommendation will give you each individual, it will give you so many recommendations for every individual finding. For example, if you take the hardware changes, right, in the ADDM recommendations, it can give you a recommendation saying that you can add another CPU, or you can change IO subsystem configuration. You will get a ADDM recommendation directly from the Oracle database like this. The examples are, the first thing is hardware changes. It will directly say you to add another RAM slot, or it will directly ask you to add another CPU. This is with the hardware changes. If you go to the database configuration, it will ask you to change initialization parameter settings. This is not happened, you can enable this one. That can be one recommendation. You can see all of them in ADDM recommendations and findings. Okay, so if you go to the schema changes, there is something called ASSM. Okay, even I don't know much about this part. ASSM is nothing but automatic segment space management system. Whatever the schema changes that happen from the Oracle DBA side, when they say that schema changes happened, you will have only 2 points. They make the schema changes by using ASSM, which is called automatic segment space management, or they do something called hash partitioning a table or an index. I can send you one document on this one, how the changes in schema will happen. This is not really required for a performance engineer, but if you want to learn in addition, you can go back and do your R&D here. Even it is a very difficult task for all the DBAs. And if you go to the application changes, right, in the ADDM findings, some of the recommendations that I saw are for application changes. It asked me to use cache options for sequences. It asked me to use bind variables, and also it asked me to use other advisors. Like I have to. It is asking me to run SQL tuning advisor on high SQL statements, or run. So if you have many of the objects, right, which are consuming high amount of utilizations, or which are some problem makers, so what it will ask you to do is, it will run, there is something called segment advisor in the Oracle pack. So when you run this segment advisor on all the hot objects, it will clearly tell you how each object is working with respect to utilization, how much time it is taking. So if we keep talking about all these different activities, right, there is a lot about Oracle database. But the reason why I would like to explain all these things is because these are all the different various reasons for anything that to happen on the Oracle database side. When you try to test, when you see many issues from many performance degradations or issues from the test that you're performing, it has a lot of it can be because of many issues from the database. If you go back and see all these database issues, it will take some 2 to 3 months to you to come to a speed and work like a junior DBA. It will take some time, but again, this is not really required. So what from a performance testing side or engineering side, at least you should know what is fixed. Okay, what value has been changed for the issue that I have observed. For every issue that you see or for every issue that you report to your DBA, you need to ask your DBA what fixed this issue. Okay, so because he will know what to fix. Again, if you're the only performance engineer who has to take care of all the Oracle DBA, you cannot do that. The project will go in vain if you're having no proper experience, no hands-on experience with Oracle database issues. You cannot touch the production database. Forget about production database. You cannot even configure the database with the application server. It is that challenging in real time. It is not as simple as configuring a sample testing application, a FAR file from WebLogic 12c installer to Oracle database. That will not happen. You'll have so many certificates, so many handshakes, so many authentications, so many firewall enabling of other values, parameters to get your web application server and database server connected. You need to have the appropriate JDBC driver which will establish the connection between the application server and the database server. It is not that easy. That is why the reason you always have a tools team, applications team, network team, and security team to take care of all the infrastructure. If something goes down, you cannot immediately bring that up. Environmental issue in the services based company will always be taken care by some X person in the team. And again, when you are the reason for migrating everything to the cloud is because the configurations or the available uptime or the availability of all the servers, the application for all the 24 hours will be taken care by the cloud vendor. If you are buying an instance to deploy your application on AWS or Azure, those guys will be taking care of all the other maintenance activities. That is why the reason you will not see the downtime and it will not give you any impact on your load testing. Okay, the reason why I explained all of these concepts is because I told you ADDM, I told you AWR. When I say ASH, what is the ASH mean? Active session history. It will show you all the average running process and active sessions that are running on the database. So, for example, a test is running for 2 hours. I have seen a sudden spike in Oracle database, and I have seen a utilization value, a maximum of 92% utilized. That is a sudden spike I observed from the CPU utilization. Can you, can you guess what could be the reason? I have seen a sudden spike in database. Till from the last 1.5 hour, the database utilization is 40 to 44 percentage. And all of a sudden I have seen a database spike which resulted in 80 to 90%. Now tell me, how can what is that I can understand from this spike? How many of you know what is DB time?
DB time is time taken to process by the processors in the DB.
Simple.
It will
Amount
be
of time.
part of the AWS report.
Right, amount of time spent in the DB to process anything. Can be anything. Okay. So, but it is the time Oracle spent performing database user calls. Okay, so the total amount of time that was spent inside the Oracle DB for Oracle database to work on all the user calls is nothing but DB time. Now, if I see some sudden spike in the database to 90%, I directly go back and I see something called ASH. ASH is nothing but active session history. This is an analytics page. If you directly log into Oracle, you will see this one. So what this ASH, in the way the ASH page will help you is it will help you to find out which sessions are consuming most DB time. Got it? So you will capture that sessions and you will send it to your DBA saying that this particular session is taking very high amount of time, which is resulting me some 85 to 90% of my CPU on Oracle database. Not only that, it will tell you the events, activity classes, the number of modules, sessions, instant IDs, and PL SQL functioning. All of them you can see in ASH page. Okay, so from the last point is from a performance testing point of view, you will tune SQL statements. Okay, you will understand, you will see which SQL statements are taking high amount of time, and you will tune using SQL tuning advisor. You will try to know the impact of the execution plan before you touch any of the SQL query, right? Before you try to optimize or tune any of the SQL query, you will try to analyze the impact of execution plan. You will use segment advisors, SQL tuning advisors, all of them that comes with an inbuilt package from Oracle database. And you need to optimize the data access paths. I told you, right? You need to know the data access path. You can optimize all of them by creating something called a SQL access, by using SQL access advisor. So what they do is you can create the views, logs, indexes. I'll tell you. This is just a very high level. I'll tell you how you can optimize the data access path, and you can use all the SQL performance analyzer, and then you can continuously repeat the steps. Okay, just to do the remaining things on this one. So, and tomorrow we'll talk about AWR report, how to read AWR report, understanding the different signs of AWR, and what are all the metrics that you need to look at, and you can see the load profile, DB time, and there are some main important metrics like DB CPU, reader size, physical reads, physical writes, and talking about user roles. And I have a sample sorry, ADDM report and sample AWR report. So to access all of them, how you have to take AWR report, what you need to understand from that, ASH application level data and AWR report data. So the most important learning aspect for a performance engineer is taking AWR. What is that you need to understand from different statistics, AWR data like time model, weight model, SQL statement statistics, how to read the AWR report. Okay, the different instance efficiency percentages. There is a lot to learn about Oracle, but there are some important metrics that you have in an Oracle AWR report. We will talk all of them tomorrow. Then we'll talk about ADDM and ASH, and after that I'll show you how to take all these reports from the Oracle database. Okay, so any questions you guys have?
No, okay.
So if you see this,
So
it is a kind of it will be a bit complicated. Even if you
Okay.
see, yes.
So normally we generate the AWR reports and the ASH reports from Oracle Enterprise Manager too, right?
Yes.
The OEM.
Yes. You
Okay.
directly generate all of them from Oracle. Okay. So
I guess
yes.
we'll be doing you will be able to do app dynamics for us, right?
Not app dynamics. I'll show you this Dynatrace one agent.
No, what I mean, the classes. Will you be able to do any class on app dynamics for us?
No, we don't have any classes on app dynamics. We have a class on
Show us how app dynamics work.
Dynatrace. Uh,
Dynatrace.
right.
I have a question. I have a question on app dynamics. I don't know if
Yeah, you can ping me. I can help you on that. All right.
yeah, yeah.
All right. We'll meet tomorrow again. Thanks all of you for joining. Because again, sorry, one last point I would like to add. So Oracle database tuning is a structural learning. Okay, it is not just it doesn't come with one or two classes. There is a plan for that, but you before I mean, if we try to understand our motto here, uh, I mean, what the question is, what you really need for your experience is the question, right? If I understand everyone's requirement correctly, whosoever joined this class, so learning Oracle database tuning as part of this course will not help you. Database tuning, I'm talking about database tuning. Attending 2 to 3 sessions for Oracle database will not help you, but the main requirement here is, the main question here is what you really need to learn for your experience. For example, if your experience is some 7 to 8 years in performance testing, when you're trying to convert some years of experience from your total experience to some saying that 2 to 3 years of experience is my relevant experience in performance engineering, out of which you're also, which is when your resume is saying that you're also a part of Oracle database tuning. Now the preparation that you have to do is, what is that you really need to know when you yourself call you as a performance engineer with 1 year or 1.5 year hands-on experience with Oracle database tuning. You need to know the AWR reports. You need to know the Oracle database bottlenecks. You need to know the few fixes of all that bottlenecks. So if you're a part of Oracle database tuning, you need to know what is the strategy that you have used, what are all the best practices, and how you have monitored all your database from time to time, and what is the APM solution that you have used. And when you monitored some 4 to 5 servers of Oracle database or different databases servers, how many agents you have installed from your APM, and how did you configure all of them to your target servers? Okay, how did you continuously monitor your Oracle database for a period of time to eliminate all these bottlenecks? This is your scope as a performance engineer, is what all you need to learn. If you go back and see PL SQL statements, if you want to know the schema changes, execution plans, these are all additional things that you can learn. But the points just explained just now will help you to crack any interview. Because even who is a, I told you right, who is a performance engineering guru having 15 to 20 years of experience, he may not know what is an execution plan. If it is a services based company, if he is a CEO practice head, he will not know anything from what is DB time, what is active session, what is the reason for CPU spike in a database. He'll not know it because he takes care of all the RFPs of all the projects in services-based companies. And you cannot expect the same kind of evaluation with product-based companies. Okay, the reason is because the one who is a senior director or an assistant vice president with 20-25 years experience, he will write a Java code. He can ask you anything and he can break your interview. So uh, learn what you need first. Okay, I told you, right, I can help you with all the questions. You mainly try to know how you can take this AWR reports in real time, how I can save it, how I can how often I have to take it, what are all the different metrics I need to understand, what how to read the AWR report is all what you need. Okay, all right, thanks all of you for joining. We'll meet tomorrow again. Okay, thank you.
Thanks.